Good day to you. This is teacher LELAND Alejandro, and we're going to continue our lesson in domain and range, finding domain and range for radical functions this time. All right, so let's see our examples for our this hour's discussion. Okay. All right, so we will begin with the problem sets under radical functions. Okay. Radical function in particular, we will be including square roots. Okay, we will be including square roots. Now, we know that we cannot have a negative radicand. Okay, the expression inside. Okay, the expression inside cannot have negative. Okay, so you cannot put something here. All right, negative values. So we will have to maintain there a 0 or higher. That means 0 to all positive values. All right, so to determine the domain, then it will have to be 0 or higher. Okay, so that will be 0 or higher. Now let's do this in a paper. So let me just put it in a paper. So this is y is equal to -4 plus 4/5 and the square root of x. Okay, so we shall try to do this in the paper. Okay, all right, I wrote the given equation. Right? The radical function is involved there. Okay, so we have here a radical, the square root of x. Now x, we cannot have a negative value there. If you can try the calculator, a negative radicand gives an error in your calculator. So this x will have to be 0 or higher. So we can very well have the domain. Okay. The allowable possible values for x will only be 0 or higher. So we will write x greater or equal to 0. Yeah, that's our domain. How about the range? The range corresponds to the value 0 or higher for x. So when x is 0, then this will be 4/5 times 0, which gives this entire term 0 value. So 0 plus -4, the value of y is -4. That will be the starting value. So the value of y starts with -4, and that is when x is 0. Now, a positive value here will increase this value. So that means this -4 will have to accumulate positive values. And so the values of y will be -4 or higher. So the range is y greater or equal to the starting value -4. The -4 is attained when x is 0. So the starting value of y is -4, and the other values will be higher than -4. Okay, so this is the answer for the first. This will be for the first number. Okay, let's verify. We shall be able to check this out in our problem set. Okay, all right. So what's the answer? There. The domain is x greater or equal to 0. The range is y greater or equal to -4. Exactly what we have in the paper. Okay, so let's continue with the next. All right, let's have the next number. Okay, here's the next, and let me just write it down so we can have the solution in the paper. There, we're now doing the second number. All right, so just remember the given is there. Y is equal to 1/2 the square root of x minus 3. And I have that exactly in the paper. We shall do this in the paper. All right. Okay, this is the second number. You can see it. What is the domain? What is the range? Okay, again, x here cannot have a negative, so it starts with 0. So it will be 0 or higher. So x is greater or equal to 0. That should be the domain. It cannot have a negative radicand. All right. Now, the starting value of the range, okay, when we will start with the x equal to 0, okay? And when x is 0, this is 0 times 1/2, that's also 0. And we will have 0 minus 3, which is a minus 3. So the starting value is minus 3. As you put values here higher than 0, this will become positive, and the value here will increase. Okay, so that means the range y starts with -3 and it goes higher. Yeah, and that's the answer. Y is greater or equal to -3. The lowest possible value for the range is -3. So this will be the answer for the domain and range, okay, for number 2. So you shall be able to check this out. Okay, shall be able to check this out. Okay, let's see the answer for verification. It's over here. Okay, answer. Domain is x greater or equal to 0. Y is greater or equal to -3. It's correct. Okay, we answered correctly. All right, let's have the next example, number 3. Okay, this is number 3, and we're asked to get the domain and range. Okay, so let's see the restrictions. All right, let's copy the given problem. Okay, this is y is equal to 4 times the square root x plus 3 minus 5. All right, and we're going to have the solution in the paper. All right. Okay, let's slide it upwards so it will be the first line. Okay, and then let me just arrange this there. Okay, I hope that's clearly visible. All right. Okay, our number 3 is y is equal to 4 times the square root of x plus 3 minus 5. All right, we're asked to get the allowed values of x and the possible output range. Okay, all right. So, all right, let's see the radicand. Okay, we call this radicand. Radicand. Okay, the term used for the expression inside the square root. Okay, radicand. Now, that should be maintained 0 or higher. It cannot be negative. Okay, it cannot be negative. So what we're going to do is set this x plus 3 expression to greater or equal to 0. Okay, there. So we will not encounter a negative square root. And then solve for the value of x domain. All right, so this will now be by subtracting from both sides, x plus 3 greater or equal to 0. We subtract 3 and subtract 3. There. And this cancels out. And we have x greater or equal 0 minus 3 is a minus 3. And we have the domain. It's there. Okay. So this is the domain. Okay. How about the range? All right. Now, just by substituting the initial value, remember, the starting value of x is -3. And it goes up to any other positive value or higher than -3, I would say. All right. Higher. All right. But the limiting lowest value is -3. So if you put -3 here, then -3 plus 3 is a 0. -3 plus 3, that's a 0. So we have a square root of 0, which is also 0. 0 times 4, that's another 0, results to 0. So we have 0 minus 5. So the value is negative 5. That's the starting value for the y. Okay, so our range is easy to see. Our y is greater or equal to negative 5 there. So as you increase the value of x here, this will have a positive amount. Okay, so say negative 2. If you make negative 2 is higher than negative 3. So when you put here negative 2, this will result to 1. So square root of 1 is 1. 1 times 4, this becomes another value. Okay, and that should be about, how much is that? That will be negative 1. Okay, okay, and that is already higher than negative 5. Okay, so the y increases. Okay, the y increases as you increase the x. So we have here the expression for range. Range is higher or equal to negative 5. All right, so that explains our domain and range. Let us see the answer. Okay, just remember our answer over here. Okay, the negative 3 and the negative 5 limits, you will find that in the other screen. All right, let's just verify our answer. There, x is greater or equal to negative 3. The range is y is greater or equal to negative 5. All right, our answer is correct. All right, let's proceed to the next. Here's number 4. Okay, it looks rather simple. Okay, so this one is number 4. We have here y equals square root of x plus 1. Okay, I can already see the answer. All right, but we will have to do some explanation before that. Okay, so let's proceed to the paper. All right. Okay, here's number 4. Okay, y is equal to square root of x plus 1. We're going to determine the domain and the range. Domain and range. Of course, that's very easy to see. X cannot be negative, so it's from 0 to the positive infinity. Okay, so the domain is x greater or equal to 0. That's the domain. Okay, now the lowest possible is 0 for x, and when x is 0, we will have 0 plus 1. So the starting value for the range is 1. So y variable is higher or equal to the starting value 1. So that's the restriction. Okay, so y will have 1 when x is 0. And then it goes higher. As you change your x, it goes higher. All right, so that will be it. This will be our answer for number 4. We shall verify. So just remember our answer. X is greater or equal to 0. That's for the domain. And then range is y, that's higher or equal to 1. And we shall be able to check that in our problem set. Okay, so, all right, there. Domain, x greater or equal to 0. Range, y greater or equal to positive 1. Okay, that gives us the answer for the 4th example. Let's have the 5th. Okay, we have this for number 5. Okay, let's write it down first so we can do the calculation on the paper. So this is y equal to negative 2 plus square root of x plus 6. This goes to number 5. So this is the 5th. All right, that's the given 5th example. Identify the domain and range. Identify the domain and range. We shall do the solution. Okay, here. All right. So we have for the domain, the radicand is x plus 6. Okay. So we shall begin with the solution. Okay, x plus 6 must be related to greater or equal to 0. Okay, it must be higher or equal to 0. We cannot have a negative value there. And then we will try to solve for the inequality. So we simply subtract 6 here. We subtract 6, we subtract 6. Yeah. And we will now be having x greater or equal to negative 6. Okay, I suppose you know how to solve inequality, okay, from basic algebra. And this gives us the domain. This is now our domain, the allowable values for x, for the input variable. Now, how do we get now the range? All right, so just substitute the limiting value, negative 6 there. When this x is negative 6, set to negative 6, this is negative 6 plus 6. It cancels out to 0. We have a square root of 0. Okay, and so we have 0 plus the negative 2. Then the first value of y is negative 2. So the range is related to negative 2 or higher. There. So this gives us the range. And we're done. Okay? The range is y greater or equal to negative 2. And the domain is x greater or equal to negative 6. And we shall find out after a little while. We shall see the problem set. Okay. Okay, what's the answer? There's the answer. Domain x greater or equal to negative 6. It's correct. The range is y greater or equal to negative 2. Exactly what we have in the paper. All right, so this is how to determine the domain and range for radical functions. Functions with a square root, okay? All right, let's have the last example. I believe we have 6 examples. All right, that's the last, number 6. We shall just finish this. Number 6 is y is equal to square root of x plus 1 plus 3. Determine the domain and range. Okay, we shall see the paper solution. All right, here. Okay. All right, y is equal to square root of x plus 1 plus 3. Okay, again, that x plus 1 radicand cannot be negative. So our solution starts with, we shall start by relating x plus 1 as higher or equal to 0. Okay, it may be equal to 0 or higher. Okay, it cannot be a negative value there. And then we try to get the possible values for x. So we simply subtract 1 from both sides to isolate the x here. So we have x plus 1, put a little space there, we subtract 1 and subtract 1 there. And so these two cancels out, the inequality is x greater or equal to negative 1. And we have the domain there. So this is our domain. How about the range? Okay, you simply use this limiting value negative 1 over here. So negative 1 plus 1 is a 0. So you have a square root of 0, 0 plus 3. First value of y is 3. That's the limiting value for the range. So y can be higher or equal to the positive 3. That gives us the range. And that's it. We're done. Okay. That's how to determine the domain and range for some functions with a square root expression. Okay. If you have something like this, simply relate it to 0. Okay. To get the limiting value. And you'll be able to determine the possible values for x. Okay. And that will be the way to get the range also. All right, so I hope you were able to learn from the examples, and we shall verify number 6, and we shall be able to see if it's correct. All right, so that will be over here. Let's verify. All right, there. The domain is x greater or equal to negative 1. Okay, it's correct. And then range is y greater or equal to positive 3. That's correct. So that will be all for now. We will continue with next lessons as we go along. Thanks for watching. I hope you learned from the examples for radical functions. All right. So see you later, and bye-bye.